This is the third video over chapter 18, linear independence. So I lied in the first video when I said there would only be two, but this is the third one. And we're going to look at example 200. We are going to make use of theorems 197 and 199 mostly. And so for example 200 part A, we have these four vectors in R4, and we want to know if they're linearly independent or linearly dependent. So we do this in two ways. The first is we make a matrix whose columns are these vectors. So we take the matrix and this is the first column, second column, third, fourth. And we put the matrix in reduced row echelon form, and we notice that we have 3 pivots and not 4. Since we have fewer than 4 pivots, the columns are linearly dependent by theorem 197. So this is the first way that we're going to do this problem. We made a matrix where we made the columns of the matrix these vectors. The second way we'll do this problem is we'll also use a matrix, but we will take the matrix whose rows are the vectors we were given. So we took our vectors and we made those the rows of a matrix. And we put that matrix in reduced row echelon form, and we notice that we have a row of zeros. Because we have a row of zeros, then the rows are linearly dependent by theorem 199. So we did this 2 different ways. We don't have to use 2 different ways, but I did just to demonstrate this. So that is example 200 part A done twice. Part B, we have these 4 vectors with very unfriendly components to them. So we look at this, we have pi, square root of 3, negative square root of 5. Square root of e, 1/7, square root of 6. Square root of pi, square root of 1/19, square root of 11, negative 101, 1/3, 19. And if we were to put this in a matrix, even making these vectors the rows or the columns and putting in a reduced row echelon form, that would not be very much fun. But all we have to do is observe here that 4 vectors in R3 are linearly dependent by corollary 194. So by corollary 194, 4 vectors in R3 are linearly dependent.